Harsh sound waves can create damage to your ear. That's why we use earplugs. However, every ear has a different shape and size. That's why we need to create personalized earbuds. Our method of stimulating the inside volume of an irregular shape is to blow a balloon in it. The formed shape gets into all the cavities of the ear canal. This project was created for Dopple, who provided us with 500 ear scans where we could make the simulations for. This is an overview of our Grasshopper script. We start off by the database of 500 ears. Then we reduce the mesh of each ear scan. We then create a bounding box around each ear scan, where we pick a point within the bounding box. Then we check if that point is situated inside the ear canal or not. If it is, then a balloon is created at this point. Now we'll start by setting some parameters for this balloon. First of all, we're defining the volume of the balloon. We're doing this by calculating the volume of the inside of the ear canal, then dividing it by a factor of 0.7 to fill up the ear canal at 70%. Other parameters for the balloon, like the pressure, the edge length, and the collision goal, are created to create the perfect shape of the balloon. Finally, we're using Kangaroo to get all the parameters and run the script, and so the balloons start inflating inside the ear canal, like you see here. Now for the electronics, we use the electronic module that Dopple provided us. However, we needed to orient the ear module parametrically. So what we did here is took the naked edges from the ear canal, joined them, and then patched both sides of it. Then we defined those patches as a surface to set a point on the surface, which you can move like this. The 2 points on the outsides of the ear canal create a vector to get a straight line from the ear canal to the outside of the ear. Next step is to take the mesh of the module, create a bounding box around it, and then determine one of the faces. Like we did before, we created a point on the surface that you can move again with a slider to adapt. Lastly, we orient the surface with the vector that we created to put the module in place. To test out the simulations, we made some 3D prints. We first made one from PLA, and then one from TPU with a foam-like material. Eventually the earbuds will be manufactured by SLA printing, which can be cured afterwards in a curing chamber.